Hey everyone, welcome back. So this is the beginning of Unit 12, which is vectors. 12.1's Introduction to Vectors. We're not going to do a lot of math for this topic right here. That'll be more in the next 4 videos. This is kind of introducing what the idea of what a vector is. So first off, the idea of a vector versus a scalar. So a lot of things we can talk about, physical quantities, can have a single number called a scalar value. These are things that have a size, whereas a vector is talking about magnitude, the size, and direction. So things that could be like scalar, for example, walking, for example, at a pace of 10 miles per hour. If I just say I'm walking at a pace of, well, not really walking 10 miles, so I'm running at a pace of 10 miles per hour, and I don't specify anything else, that's a scalar. But if I talk about the idea of I'm now running due east at 10 miles per hour, now that's a vector because it's talking about the different direction going on there. So again, speed, scalar, but the velocity, which refers to direction, is going to be the vector. So if I have a boat traveling at 15 miles per hour, again, it's traveling at a speed, but there's no direction being referred to, so this would be a scalar quantity. Whereas a hiker walking 25 paces due west is referring to a vector, because it's talking about the direction as well as a certain magnitude itself. Now, it doesn't have to be talking about speed or velocity. The idea of weight is also a vector. And the reason for that is because weight is based on your body mass and the acceleration due to gravity of whatever planet you're on, moon, or whatever you're currently located. And the acceleration due to gravity is a vector that's pulling an object down. Hence, it's going to always refer to the overall weight as a vector. Just a person's mass, that would be a scalar. So vectors are pretty much just lines with arrows in them. We have what's called an initial point or the tail. That's where it starts. And then it ends at the terminal point or the tip. And we use notation like you might recognize from like using rays. This little notation right there over top it to show the vector. The initial point is also considered the standard position. The direction is where it's going as you compare it versus the positive x-axis. So this example right here, it's got a direction of 35 degrees because that's its angle difference versus the x-axis. The magnitude is the actual length of this thing. So this particular graph has a scale of 1 centimeter to 5 feet per second. So if you actually were to measure this, this is really, well, probably not right now on your screen, depending on how you scoot up, but from the textbook this was in, it had a length of 2.6 centimeters. So you multiply that by 5. So it would represent a vector that's really 13 feet per second. When we get into this kind of stuff, we're not going to be using rulers for this kind of part. We'll talk about this in future topics where I'm going to give you coordinate points that creates the vector, and we'll find the magnitude based off those coordinate points using essentially the distance formula and the Pythagorean theorem. So vector types, so we've got parallel vectors, equivalent vectors, and opposite vectors. So parallel vectors have the same or opposite direction, but not necessarily the same magnitude. So like for example, if I have this vector right here, vector A, and then this vector right here, vector B, obviously B is bigger and it's going in the opposite direction, but it is going to have, it's the same orientation essentially in that they're parallel to each other if you create them as normal lines. Equivalent will have the same magnitude and direction. So like this is like if I have this vector C over here, if I kind of draw it to, well, without those extra lines that kind of got created, to be the same length as A, those would both be equivalents. Whereas opposite vectors, if I were to draw this vector here, D, it looks to be roughly the same size as C, but it's going in the opposite direction. That's now an opposite vector. So if you see that kind of terminology, that's what they're referring to. Now we can put two vectors together in two different ways, either called the triangle method, which goes tip to tail to create a resultant vector, the summation of those two, or the parallelogram method where you do tail to tail, and you create a parallelogram based on that, and the diagonal is going to be the resultant vector of the two vectors adding together. Again, we're not going to worry about drawing this kind of stuff in class. We'll be more mathematically talking about how to get the resultant vector when I do A plus B or A minus B or whatever it is I'm trying to do. These are your two options. Either you do tip to tail, so you do one vector, then you draw the next vector, and then you connect them, kind of like the hypotenuse, that's the resultant. Or again, they both put both their tails together, create the parallelogram, and then the diagonal is the resultants. Either one is the same thing really, just different ways to create it. And if we are multiplying vectors by a scalar, which we'll explore a bit more, you can do that. Multiplying two vectors together requires different operations, things like dot products and cross products. That's not as just simple as just multiplying numbers together. There's a lot going on for that. But in general, if it's a scalar multiple, kind of like our matrices, you can just, or distributed property, you just multiply each piece of the vector by that scalar. If the scalar is positive, you go in the same direction. It'll just be bigger or smaller based on what the scalar value is. Whereas if the scalar is negative, it's now going to go in the opposite direction. So like if I have this vector A right here, and I'd say vector B is going to be twice vector A, it'll do in the exact same direction, just would be twice that vector. Or if I say vector C is negative A, then it'll just be the same thing as A, but now in the negative direction. All right, so that's just some terminology. Nothing too obviously strenuous mathematically. We really didn't do anything math-wise. It was more some couple logic tests in the beginning about whether it was vector or scalar, and then just some other definition information. We'll get into the more math stuff as we go through the rest of the unit. We have 4 other videos for that. So I'll see everyone next time with those videos.